Check. So, good morning, students. In Unit 2, we have been discussing the composite cylinder concept. In composite cylinder concept, we are seeing what is critical radius of insulation. Critical radius of insulation. Okay. If I want to define this critical radius of insulation, it is the radius of insulation at which the heat transfer is maximum through the insulation. Okay, we have taken this one itself and we have said that it is maximum. Okay, for maxima condition, we have taken dou Q by dou R2 is equal to 0 and then solved and got that R critical is equal to R critical is equal to K by H. That is the ratio of thermal conductivity and the heat transfer coefficient. Okay, that is the ratio of heat transfer by conduction and heat transfer by convection. Now, let us look at a problem wherein we'll try to understand this bit better. Okay, yesterday we have seen a wire concept and understood this wire problem and understood this concept. Now, let us take one more problem to understand this. Okay, I have updated this particular problem in that Google Doc I have shared with you. You may refer to the same. This is how this question goes. Here you have a copper pipe. There is a copper pipe here. So it's circular. It's got to be circular for you. So if I have to draw it, it's like this. And then a refrigerant is flowing inside it, and the value of it is minus 20 degrees centigrade. And the OD is given as 10 mm. Let me write that R1 is equal to 10 mm by 2, which should be giving you 5 mm, and then is exposed to a convection. So there is a convection environment around, and that environment is H is equal to 50 watt per meter square Kelvin. And the air here at the outside is 25 degrees centigrade. It is proposed to apply an insulation of conductivity 0.5 watt per meter Kelvin. That is, what you want to do is you want to actually add an insulation here. You wanted to add an insulation layer here. And this insulation layer is having so and so thickness and so and so K value, that is the thermal conductivity value. So for this K value is 0.5 watt per meter Kelvin. Most in most of the cases, the K value is very less. Okay, for insulating materials, the K should be very less. That's why they are called insulating materials, because the thermal conductivity value is very less. They can actually, insulate the thing and stop the heat transfer. Okay, so that's what K value is given, and determine the thickness beyond which heat gain will be reduced. Okay, so what he is asking is, in a way, he is asking you to find what is RC. Okay, according to this, what is R critical? He is asking you to find. Calculate the heat gains. Okay, what is the Q when this one is there, this one is there, this one is there for 1 meter length. Okay, so Q is equal to at 2.5 mm. Q is equal to T is equal to 5 mm. Q at T is equal to 7.5 mm. So these values he is asking you to find. Also, he has given that the L value is equal to 1 meter. So this is the thing, and you have to find out the Q through it. To find out the Q through it, what you have to do is you have to take like the resistance circuit. If I take the resistance circuit through here, okay, so that is two resistances will prevail here. One resistance is due to, sorry, one resistance is due to the inside thing, and the other one is due to the insulation. Okay, along with this, he is also asking you to find R critical. If you want to find R critical, what is R critical? To find this is very simple. It is K by H. The K value is 0.5, and H value is 50. So somebody calculate this and tell me what is the value of this one.
0.01.
It is 0.01. What is the unit? It's the meter. Okay.
Correct, sir. Correct.
It is meter. Okay. You are done with your R critical now. You have your uh, what is this? The resistance circuit. This side you have minus 20 degrees centigrade. The other side you have 25 degrees centigrade. Here you have 1 by HA, R due to convection, and here you have R due to insulation. So if I want to write the Q here, the Q value will be the delta T by the R insulation plus R convection. So I will write this R insulation. R insulation is nothing but your hollow cylinder concept. For hollow cylinder, it is 1 by 2 pi KL, 1 by 2 pi KL ln higher radius. Let me call this R2 by R1 plus the R convection value is 1 by HA. 1 by H I will have. A is 2 pi into R2 into L. That is 2 pi RL. R2 is the radius of the outer thing. Okay. So here what is given for us is, you know what is delta T. Delta T is the minus 20 and 25 difference you will take, you will get this. Okay, K value of the insulation, you know, L, you know. So R2 you have to take appropriately here. So for first Q, that is thickness is equal to 2.5 mm. If that is the case, what will be the R2? Somebody tell me this. It is R1 plus T. The R1 value is, it is 10 mm by 2, that is 5 mm. 5 plus 2.5 mm. 5 plus 2.5 mm. So that will give you 7.5 mm. So what you do is, you do Q at T is equal to 2.5 mm, or R2 is equal to 7.5 mm. If you do this, the delta T on the top will be something like 25 minus of 20 you can take. Otherwise, you can take like minus 20 minus 25. Okay. Anyways, you have to take the positive value. If you want to take the positive value, you can take it like this. If you want to take it to a negative value, you can take it otherwise. Okay, that's not a big thing. It's not a thing. We write it like R2 is equal to 7.5. So here what I have is 1 by 2 pi KL. The K value is 0.5, L value is 1, and Ln value, sorry, Ln into the higher radius is 7.5 by the lower radius is 2.5 plus the H value unit 1 by H. The H value is given as 50 watt per meter square Kelvin in the question. 50 into 2 pi into the R2 value is 7.5 and the L value is 1. So tell me this value, calculate and tell me this value. What is the Q value?
Eighty-one point three six watts.
81.36 watts. Good. So the same way you will go for Q at T is equal to 5 mm. If T is equal to 5 mm, then R2 will be plus 2.5. So 5 plus, sorry, it's not plus 2.5, it is plus 5. So 10 mm you will get here. Okay. So this will be 25 minus 20 by 1 by 2 pi. K value is 0.5 into Ln. The R2 has changed now. It is 10 by 2.5. Okay, in place of 7.5, in place of 7.5, I have to change the appropriate values here. So 1 by 50 into 2 pi into the 7.5 place, I'll get 10. See here, it should be 7.5 into 10 to the power of minus 3 actually. 10 to the power of minus 3 to convert it into meter. Here I need not do that because here they'll get cancelled in the numerator and the denominator. Yeah. Somebody tell me this value. Calculate and tell me.
83.49.
83.49 watts. Good. So Q at T is equal to 7.5 mm, meaning R2 will be equal to 7.5 plus 5. That will be 12.5 mm. That is the R2 value. So in place of R2, we have to replace the values accordingly. So it is 25 minus 20 by 1 by 2 pi 0.5 into L into Ln. In place of 10, you have to put 12.5. That's 1 by 50 into 2 pi into 12.5 into 10 into minus 3 into 1. Now, somebody tell me the value. What is the value of this?
46 watts.
What is that?
82.46 watts.
82.46 watts. Good. So let me tabulate what I got so far. At R2 is equal to 7.5 mm. What is the Q value? It is like 81 point what? 3 somebody 36. At R2 is equal to 10 mm. The Q value is 83.49. At R2 is equal to 12.5 mm. The Q value is 82.57 watts. See here, let me put all these values on a graph. I have put them on graph. Here I will take R2. On y-axis, I will take Q. If that is the case, see when R2 is 7.5. This is the R2 7.5 value. This much Q is there. Yet 10. What is the Q value? It increased. So it should be somewhere over here. And at 12.5, it decreased. So it should be somewhere over here. See, from this, if I draw the graph now, if I draw the graph goes like this. Can you see that? So what we can see from this is there is an increasing trend first, and then it will reduce. Okay. So what is this point? The point 10, whatever that is there for you here, it is nothing but your critical radius of insulation. That is RC that you have found out, the K by H. It is nothing but 0.5 by 50, which is equal to 10 mm. Okay, it is 0.01 meter, which is actually 10 mm. That is the reason why at this particular point you are witnessing Q max. So RC is a point where you'll be having Q max. So that will be very clear to you now from this particular problem. In the last class, there might be some confusion, but now it should be clear. Any questions at this level? Is this clear? You don't have any questions? Yeah. Let me move on to the next problem. See all the problems that I am putting here. I have updated them in your Google Doc. You can refer to your Google Doc. There, all these problems will be available to you. Right, let's solve this problem now. See, here in this problem, there is a tube with so and so diameter. So again, it's a circular shape. It's like, and then maintained at a uniform temperature. Let me write this D first. For this particular D is equal to 2 centimeters. That means R1 will be equal to 2 by 2, that is 1 centimeter, at a uniform temperature, and is covered with the insulative tube covering. Okay, the given thing is having an insulation like this. Okay, this complete thing is your insulation. This is all insulation, and the K value of this one is given as 0.18 watt per meter Kelvin. Watt per meter degree centigrade is also equal to watt per meter Kelvin. In order to reduce the heat loss, okay, heat is dissipated from the outer surface of the cover by natural convection at H is equal to, so outside the H value is given as 12 watt per meter square Kelvin into the ambient air at a constant temperature. Determine the critical thickness of insulation. So what he's asking is, he's asking you to find what is R critical. That is the first thing. Calculate the ratio of heat loss. So he's asking the ratio of heat loss. Q by Q he is asking. Ratio of heat loss from the tube with insulation to that without insulation. So Q with by Q without, what is the value he's asking? Insulation. For the thickness of insulation equal to critical thickness. So in the first case, the R is equal to RC. That is R critical. That is the first thing. And there is one more case here, Q with by Q without you have to find. And in this case, the thickness of insulation is 2.5 centimeters, thicker than the critical thickness, 2.5 centimeters plus RCR. These are the things he is asking you to find. Okay. So here, if you observe, the temperature is not given. Okay, the temperature value is not given. He said that initially uniform temperature is maintained. Okay, and ambient is at a constant temperature. He said, but he has not given you the values. So if that is the case, how you can do that? See here, he's asking you the ratio. Because of that, whatever the delta T is there, it is same in both the cases. So the delta T will get cancelled in the numerator and the denominator. So that's why he did not give you the temperature values and he's asking you to calculate that. Okay. So if you want to find out this R critical here, the R critical is again K by H, simple. The K value is 0.18 and the H value is
0.018, sir.
what is that? You are telling the R critical value,
0.015.
0.015 meters. That is 1.5 centimeters. So that is what R critical you are asked to find out. Okay. So that is your R critical. That is asking you to find out. And Q with by Q without you have to find out. So Q with by Q without. If I take this in the numerator, you will have delta T by with means you have to take it like 1 by 2 pi KL into ln R2 by R1 plus it is 1 by HA on the other side. Okay. If you take that 1 by HA, it is 1 by H into the A value is 2 pi R2 into L by there is no uh, insulation in the second case. If there is no insulation in the second case, what happens? You will not have this term. This term will not be there because the solid cylinder of insulation will not be present. So that term will get removed here. So what you have is simply 1 by HA. It is 2 pi into R2 into L. So here what he said that is the R2 is equal to RCR. The first case he said this. And this value is 0.015 meters. I just found it out. It is 0.015. The delta T you can cancel down. And if you write this equation will be something like this will come into the numerator because it is 1 by here. So I'm writing it as like 1 by H into 2 pi R to L by 1 by 2 pi KL ln R2 by R1 plus 1 by H into 2 pi R2 into L. So this is the thing. You substitute the values. The H value, what is the H value that is given in the question? It is 12, right? So you substitute all those values here. 12 into the 2 pi into the R2 value is 0.015. And the L value, is it given in question? L value is also not given in the question and L can be cancelled out. Okay, you need not have L actually. Okay, let me write it properly like take out L here and cancel that here. L in the numerator and denominator will get cancelled by 1 by 2 pi into the K value of the insulation is given as 0.18. 0.18 into the ln. The R2 value here is 0.015. 0.015 by 1 centimeter. That is 1 into the R1 is 1 centimeter. 1 into 10 to the power minus 2 plus this is 1 by the same expression I will get here 12 into 2 pi into 0.015. So tell me what is this value? This is for Q with by Q without when R is equal to RCR. R2 is equal to RCR. Somebody tell me what is this value? Calculate and tell me this value.
0.288.
0.288.
Sir, is it 0.08?
No.
0.91.
0.91 would be correct. Okay. Yeah. So this is the case when you have the R2 is equal to RCR. The same expression you can repeat by changing these values. This 0.015, this 0.015, this 0.015. If you replace it with appropriate R2 value, that is Q with by without, when R2 is equal to what is given? The double thickness, right? Let me go to the question. Yeah, this 2.5 centimeter thicker than the critical thickness. So that is, I have to add 1 centimeter with 2.5 centimeter. So here, this will be 3.5 centimeters. No, it's not with 1 centimeter, right? 1 centimeter is your R1. You have to take it with RCR. It is RCR. The RCR value is 0.015 plus 2.5 into 10 to the power of minus 2. Tell me what is this value? The R2 value? 0.035 meters. So,
Sir, 4 centimeters.
sorry, yeah, it is 0.04. 1525 is 4. Yeah. So this will be like 1 by the H value is 12 into 2 pi into 0.04 by 1 by 2 pi into 0.18 into ln 0.04 by 1 into 10 to the power of minus 2 plus 1 by 12 into 2 pi into the 0.04 will come. The same expression that I have previously, only R2 will change. Okay. So somebody tell me what is this value?
Sir, it's with by without, right?
Yes. With by without. Tell me. You want to ask a question or what?
Nothing, sir, nothing.
Rahul. What is this value? Somebody please tell me this value. The second case. Did someone calculate that? No one has calculated it.
Sir, is it 2.554?
No,
Sir, is it 0.3?
it should be less than 0.9.
0.391.
0.39. Everybody is getting the same value.
Sir, I got 34. 0.34.
I don't know. I did not do that, but you cross check with others. So the point is, it will be less. Okay. So here, if you keep on increasing the thickness now, what happens? The heat transfer increases. When the heat transfer increases, uh, this is that is. Let me show it in graph. You'll understand it better. Q and R2. This is the case. Previously, you are here. This is your first case. The second case is somewhere over here. Okay. If you have to represent this case, the Q by Q with by without Q with like okay, this is the thing. That is the reason why it should reduce. Okay. Right. That's all from me for today.